We're going to record. Here we go. All right. Change in tandem part 2. So we're on part 2, which means that today is our day 2 of working with change in tandem, which is just how are you changing from one point to the other, right? Fancy words. All right. So we've already did examples 1 through 3. We're now focusing on examples 4 through 9. Now, coming up, we're going to talk about what's called points of inflection and concavity. Okay, concavity and points of inflection. An inflection point is where a curve changes from being up to becoming down. Okay, that's what an inflection point is. When does that happen? All right, well, at this level in our lives, mathematically, we're not able to calculate that, right? We're just going to approximate and learn some ways around it because you actually need calculus to do the actual numerical calculation. And is that what our class is? No, we are pre-calculus. So in calculus, you will learn how to find the exact points of inflection. Got it? We are going to just work on finding what we can and identifying where it's concaved up and concaved down. All right? So when we look here, we want to point out that when we're talking about concavity, we're describing what's happening at each point. What is the slope at every single point? So typically when you're learning slope, you've learned slope, just a linear equation has slope, right? It's not true. There is a slope at every single point. So if we look here, let me be great. Let me be great. We're going to try that again. So if you look at the first point, we're going to follow its path and identify its slope. There we go. So notice at this point, this is your slope. That means that if I was to try to find a slope that contain a line that contained this point only, this is what it's doing, right? Notice it's going do, and then I do to this point, do, go to this point, do, go to this point, do. Your slope is increasing. So when we're describing concavity, we're asking what is happening to the slope at each point. So when it's concaved up, the slope is increasing. See that? Yeah. When it's concave down, your slope is going to be decreasing, and it's decreasing because you're going from a positive slope to a negative slope. Do we see that? All right. That's all the general idea of concavity. Make sense? All right. Here, we're going to analyze this function. It's function g of x. And we want to be able to make sure we're comfortably identifying where it's increasing and decreasing, which we went over on Tuesday, correct? Identifying where a function is increasing and decreasing. So really quick, so one, where is g of x increasing? Okay, but remember when we're describing intervals of increase, we use only the x variable. -3 to 2. Good job. Right there. All right, now I did my research. Remember I told you I was going to go look it up and see how they want us to write it? Yes? Okay. They want us to make sure that we're using brackets, not parentheses, for describing increase and decrease. Okay? So our answer would be -3 to 2 is one interval of increase. Agreed? Where is my other interval of increase? 4 to infinity. Because it goes on forever. And you end it with the parentheses, because can we stop infinity? No. So we start at 4 and we continue to infinity. Okay? Yes. You will lose points because you will lose points on an FRQ if it's not in brackets. Infinity is the only thing that should have a parentheses. Okay? All right. Our intervals of decrease. Where do we decrease? Go finish. Infinity. What kind of infinity though? So we start over here at negative infinity, and then we are decreasing. And again, we're only going to use the which variable? The x. So we're decreasing from negative infinity to -3. And where else do I decrease? From 2 to 4. Okay, I wanted to point out this because a lot of times when we're describing concavity, we have an accidental tendency to mix it up with increasing and decreasing, okay? So we now identified our increasing and decreasing. Now we're going to talk about how you identify where a function is concave up and concave down. When you're looking for your concavity, you're looking for where does it start to where does it end? Where do I change direction, okay? That's going to always be between your high and your low points where it stops. So for example, this is going to be what? Is this this is concave up, right? Do we see that? It's a U, it's going up, concave up. I went from decreasing slope to a positive slope, okay? So it's going to be concaved up. Let's go back and look. So concaved up, we are, think of a contact. You always read a graph from left to right. Yes. All right. So we read, this is going to be our concaved up. Notice I stop right here. Your stopping point of concavity is halfway between your minimum and your maximum. So I'm concaved up and I stop here because this is the halfway point between my min and my max. Make sense? All right. You're going to always stop there. No, it's going to always stop between the min and the max. Like not in the third quadrant necessarily, just where your min and max are. We're going to write it in a second. All right, so over here, continue to read. Where else am I concaved up? So not from 2 to 5. It's going to be 3 to 5. It's the halfway point between the min and the max. So this is my other concave location. 3 to infinity. So we're going to now write it. So my points of concavity, concave up from negative infinity to, I put my 0 in the wrong spot. You see nothing. To 0.5. Now, concavity is always going to be parentheses for all. Parentheses for all is concavity. And my other location, concavity is going to be parentheses for all. Yes. Yeah. When you have concavity, it's going to be parentheses for all. The way I think of it is the double C's. It's 2 C's. So I think CC, CC. All right. And then the other one's going to be at 3 to infinity. Okay. So now that we've identified where it's concaved up, the question is asking, at what interval is your function increasing and concaved up? So notice how I highlighted my concavity and we've labeled our increasing interval. At what intervals do I have highlighted pieces and an I? So -3 to -0.5, perfect. So from -3 to -0.5. And then where else am I highlighted and increasing? 0.5, yes. Where? And then that's where I'm increasing and I'm concaved up. Do we see that? So it would be, there we go, 4 to infinity. You're looking for concaved up and increasing. So you're looking for words. Yes. Anytime you're describing concavity, it has to be parentheses. Okay. How do we feel? Does the highlighting help to see that yes. That's not here. That's geometry. Being convex, that's a geometry term. Don't bring it here. No, it's talking about your angles, whether inside or outside of the polygon. Yeah.
What I'm saying is, instead of saying concave up and concave down, you say concave and convex.
They're different. So I'm telling you, we don't use that. That's geometry. All right. So now we're going to do concave down. So I'm going to change my highlighting. And where am I concave down?
0.5, 3, 3.
Boom. That's where I'm concave down. Agreed? It's only one. It's only one. That was the last piece of the graph, right? So we're concave down from negative 0.5 to positive 3. Again, I'm using parentheses for concavity. CC. Okay? And I did a poor job of labeling my intervals decrease.
Sorry, so the midpoint on both sides.
It's always between where it starts and stops is always the midpoint between all maxes and mins. Yes. Those are going to be your points of concavity. Or it changes. Because that's the point where they are meeting, right? Where I'm changing from being concaved up to being concave down. All right, so the question asks, where am I decreasing and concave down? Just from 2 to 3, perfect. So that's where my green and my D collide, and that's only from 2 to 3. All right. Increasing, decreasing, concave up, concave down. We're good? Okay. The concavity is new. Increasing and decreasing is not. No, but you will on Monday.
On Monday.
Quiz.
Put that in my little.
It's on your canvas and on the handy dandy calendar on the board.
I was inspired by Lily.
Good job. I'm so proud. All right, intercepts. Intercepts, this is not a new concept. This is a review concept. Got it? Not new, but review. So we have two types of intercepts. We have x-intercepts and y-intercepts, okay? Your x-intercepts of your graph are when you cross the x-axis, right? Algebraically, you're saying when f of x equals 0, correct? F of x represents what? Y. But yes, when y equals 0. Okay? F of x is saying when your y equals 0, that's your x-intercept, right? And we write it as x comma 0. Agreed? All right, moving on to y-intercept. I just summarized what was read. All right, y-intercept. Your y-intercept is graphically, where do you cross the y-axis, right? What are you saying algebraically? It's when x equals 0. What is the function? Okay, so if x equals 0 is part of your domain, then guess what? You have an x-intercept. If it's not part of your domain, will you have an x-intercept? No, because it's outside of your domain. It doesn't exist there. Okay, so keeping that in mind, not every function will have a y-intercept. Not every function will have a y-intercept, and not every function will have an x-intercept. It all depends on the domain and the function itself, okay? So y-intercept. Y-intercept means that we are letting x equal 0, and what we come out with is our ordered pair 0, comma, y. Agreed? All right, so graphically, we should be killing it on example number 5. Yes? Yeah. What's my x-intercept or x-intercepts on example number 5? We have -3, 1, and 4. We can write it as a set. Don't judge my braces. -3, 1, and 4. Those are actually fairly decent for me. It happens to the best of us. Our y-intercepts. Where are our y-intercepts at? Where is it? I'm sorry. -3. Y-intercept is only 1. You can only have one y-intercept, so I'm going to write it as a ordered pair. Because if I have more than one y-intercept, am I a function? No. Because who does not repeat? Your x's. Don't repeat your x. Okay. Now, let's talk about it algebraically. I knew we would do great graphically, but let's algebraically calculate our x and y intercept, okay? We'll do our, which one first? Let's do x-intercepts first. So x-intercept is, no, let's do y. It's vector. We'll do y first. So for your y-intercept, that means that you're gonna let x equal 0. So we're looking for f of 0. Does that make sense? Because we're letting x equal 0. Everywhere there's an x, it's gonna become a 0. So we have 0 to the third minus 3, 0 squared, minus 4 times 0 plus 12. What happens to all those zeros? You cancel out. You go away. Bye-bye. So where is my y-intercept? At 12. That's how easy it is to find your y-intercept. All right. We're good with y, right? All right. X is where it gets a little tricky. And that's because x is saying that you're letting your entire equation equal 0. Does that make sense? So it's saying if I let this equation equal 0, what is my answer? So if I let 0 equal x cubed minus 3x squared minus 4x plus 12. The only way to solve this without a calculator is that we have to F-A-C-T-O-R. What does that say? Factor. And because there are 4 terms, this is factoring by grouping. So I'm going to group you, and I'm going to group you, and I'm going to group you. Is this ringing any bells? Okay. If you did not like factoring by grouping, you could also use the box. Is the reverse box. You're filling it in and then figuring out the GCFs. Greatest common factor all the way around. Does it matter which one you use? No, because you have the choice and the choice is always yours. Okay. So if you're a box person, all you're doing is finding the greatest common factor of each row and each column. Please tell me this is ringing some bells. Huh? Well, we're gonna do both. With the parentheses, you're also just finding what is the GCF between these two numbers. What is the GCF between these two numbers? Yes. We're factoring. Foiling is what leads to this. We're undoing FOIL. So what is the GCF between x cubed and 3x squared? X squared. What is the GCF between negative 4x and 12? Negative 4. Remember, if your leading is negative, then the GCF is negative. So when I factor that out, I'm left with x squared times x minus 3. Factor out the negative 4. And I'm left with x minus 3. I am. One of them. One of them. There's 3. All right. We're gonna see. What do they have in common? X minus 3. So when I take out x minus 3, what am I left with?
X squared minus 1.
Wait, what, you took out x minus 3?
I factored it out because it's what they have in common. And those are my factors. And you take each one and set it equal to 0, and then there are your answers, okay? Let's do it on the box method. Ready, box people? GCF everywhere. What is the GCF between these two numbers? Perfect. What's the GCF between these two numbers? Negative 4. What's the GCF between these two numbers? X. What is the GCF between these two numbers? Do I still end up with the same factors? Yeah. Did I end up with x minus 3? Yep. Did I end up with x squared minus 4? Yes. If you can do grouping and grouping is not your thing, then you can do reverse box. Okay, reverse box tends to work for more for your visual learners. So we can all see it. And that is perfectly fine. All right. So whichever method best works for you is the method you should utilize. All right. The key thing here is once you have it. What? Oh. Or Punnett squares. All right. And then, so now you just set each factor equal to 0. I don't have enough room down here, so I'm going to do it over here on the right. So I have x minus 3 equals 0. What is x? Positive 3. So one of my x-intercepts is at 3, 0. Then I have x squared minus 4 equals 0. I add 4 to both sides, and I get x squared equals 4. I take the square root. When you take the square root of a number, it produces a positive and a negative. So my last two intercepts are at 2, 0 and negative 2, 0. And those are my x-intercepts. So remember I said y-intercept is easy peasy. X may require a little extra effort. Do I need to zoom back in for anyone? I can't. Speak, Lily. Yes. The pass is on the back of the door. All right. Yay, nay. What are our comments, questions, concerns? Attack me. Okay. All right. So next part. Our favorite part is applying it. Oh my gosh. Yay. Applying our knowledge. So exciting. I know. Up first, we're going to start off with a linear example of a word problem. Linear. Okay. Don't come for me. It's linear. It's nice. It's smooth. We're going to be friends. Okay. Oh my gosh. All right. So we have Tina is a sales clerk at Electronics Depot who earns $325 base pay plus $18 for each item sold. Express her gross salary G as a function of the number X of items sold. So one, you're going to create an equation. That's what it's asking for, right? If I'm asking you to express something as a function, I'm saying, what is the equation, right? Once you have your equation, you're going to find her gross pay if she sells 24 items. I'm going to give you 2 minutes at your table to figure out the equation and her gross salary for 24 items. All right. Let me start the timer. Yeah, you can. In algebra 1? In algebra 1, maybe? Oh, 11. We have to use a calculator. You got your clever? Oh, clever.
Damn, she doesn't.
That's exactly log in. I like to just type it in with the major.
How much you make? Oh.
It's gonna be clever.
You're going to try to tell us 24.
Or.
Yeah. Makes $31 an hour.
A lot. I wonder if she lives in California.
What the planet knew?
It's the one you ever heard about.
There's a load on the phone.
Nothing longer make you log in.
Yes, it does.
It's a sad and tragic.
That's
Oh, no, talk to your peers. I know, but. You gotta talk to peers. You double check with your peers. Double check with your peers. That's what I'm saying. No, I'm gonna have, what is it called? Progressive struggle. Progressive struggle. We're out here. Progressive.
No, it's this plus.
So,
We're starting this.
Joking, you're not joking. No.
it's recorded. The recording's on.
Why didn't you pause the recording?
Because I forgot, Hudson.
Well, then that's your fault.
Okay, it's your fault for saying it.
That is not my fault.
It's your fault. I know, I was just saying, now, why didn't you do it? It's your fault. Come on now. It's wrong. That's what I'm saying.
What?
Josh, thank me for asking for help.
You said it again. You said it.
He's good.
Hold on, I gotta.
Yeah,
find it how quiet.
Wait, we do both, right?
Hey, well, actually.
Alright.
Who else answers out?
So late.
Two wrongs makes it right.
We'll fix it. I'll be editing this apparently.
Go ahead.
Okay. Algebra check. How'd we do?
I don't think I did good, because something is not helping me and I need help.
So I gave you the hint that this was linear, correct? Because it's linear, you know you're in the format of y equals mx plus b. So you need to establish what is her m and what is her b. So in this case, I was even nice and said base a to try to lead you to what your b was. It says base pay, right? And then 18 for each. So number one thing you should have left algebra 1 knowing is anytime it says each, per, by, that is your slope, correct? That value is your slope. Okay, so when we write our equation, her salary, so it says your salary is G. So her G of X equals what?
325 plus 18, comma, F, I mean, parentheses, F.
18x. That's her equation.
And then you have to do 18 times 24.
And then it says, what are your 24 items? So G of 24 equals 325 plus 18 times 24. So what is her salary? $757. Doesn't matter what order you wrote it in.
I would like that.
That's fine. 2 plus 3 and 3 plus 2 is the same thing. Okay, now that was coming from algebra 1. That's something we should be able to do. When we see it, we don't panic, we read. Key things to notice, our beginning. Remember, y-intercept is your beginning. Per, each, that's, guys, that's your slope, okay? On next one, this is literally from algebra 2. Straight from algebra 2. If your pre-calculus book is dropped from a height of 45 feet on the planet Newton, its height in feet after t seconds is approximately h of t equals 45 minus 14t squared. How long does it take for the book to hit the surface of the planet? Okay, what are you calculating here?
The gravity.
The time, it's asking for time, right? Given the fact that you're going to hit the surface. So knowing that it's asking when time equals something, you're going to be where? Your height is going to equal what? 0. That's what it's asking, correct? So from the problem, it's saying your time equals what when your height is 0 because you've now hit the ground. All right. So how do I solve this? Algebraically, what am I doing?
You're plugging 0 for height and you solve.
I'm plugging in the 0 for the height. So we have 0 equals 45 minus 14t squared. Tell me what I'm doing. I'm going to subtract the 45. That eliminates it. I'm left with. All right.
5 by negative 14.
what do we get? I'm just gonna leave it as 45/14. Then we take the square root. And from there, I plug in the calculator. So we get t. In this case, are we going to worry about the negative value of the square root? No, because it's time, right? It's a real world example. So we're only focusing on the positive, and in the calculator, you put that in, and you should get approximately 1 and 700. And that's how many seconds it would take on planet Newton.
Is that even a planet?
Yeah, Randy? Yep.
Yeah, it's in the lines.
It's part. When we are doing problems that are non-calculator, you'll know.
Friday for this class.
All right. Okay. So basic applications. So this is our toe into applications. The key thing for applications is that they are usually the easiest problem. The hard part, like algebraically to do, they're the easiest. The initial part is the setup, and that's where you get stuck at. Okay. So we're going to work on these applications so that we don't get stuck at the setup. Because was the math terrible? No, it's the setting up and recalling which function, which rule I'm following. Okay. That's where it gets us stuck. All right. Now, comparing functions graphically. So what this is asking us to do is you're not just given one function anymore. Okay. We took a step into this when we did function composition in Algebra 2. But you're going to be given multiple functions and you have to be comfortable analyzing them in any format of which is graphically, numerically, algebraically, or in written form. In this case, we have two graphs, right? And we need to be able to read both at the same time and decide which one we're analyzing, okay? So what I would like for you to do, you're going to go through example number 9 at your table, answering the A through I, yeah, right? A through I, whatever it is. A through I as a table and checking yourselves. So if y'all like to split it up, come back and review, say, hey, you do this, or you work through and check, do one problem at a time together. That's fine as well. But I'm going to give you some hints before you get started. Is that cool? All right. So, and as you finish this, then you'll go on to your assignments. Well, we have an activity. I forgot 2 truths and a lie. Hopefully we'll get, yeah, with a partner. It's math, 2 truths and a lie for the people.
Math?
Yeah. It's math. All right. So domain. Domain is asking you what's happening from left to right of your graph, correct? Yes. Next, values is asking you the value of the function. If I'm looking for a value, it says 0. This is saying y. So I'm going to go to the y, go to 0, and I'm looking for what gives me 0. Does that make sense? When does y equal 0? Okay. This is what this is asking you. It says, this is saying when y equals 0. That's what it's asking you. So when it says f of x equals 0, g of x equals 0, I'm asking when does this happen? Okay. Next, on C is asking you when are they equal? So I'm asking for when do these two graphs intersect? Does that make sense?
Oh,
If I'm asking when they're equal, I'm asking when do they intersect? Yes? Okay. On D, it's asking when is f of x greater than g of x? So if I'm looking for when f of x is greater than g of x, I'm asking when is f of x on top? Make sense? All right, then if that means on top, this means I'm looking for when f of x is on the bottom. Okay. It'll be an interval. Yeah. It should be an interval of when it's happening. It starts here and it ends here. That's an interval, right? All right. Yes, that's it. Exactly. Yes. So on the next one, as Hudson said, this is asking when is g of x greater than 0? So you're asking when is g of x positive? When do you have positive y values? Okay. That's what that's asking. When do you have positive y values? So if greater than 0 means positive y values, what does less than 0 mean? You're looking for negative y values. Yes?
Is that negative x values to the f of x? No,
It's y values. No, you're not. You just asked a question for clarification. All right, next it says the values of x such that f of x is increasing. Okay, so you're looking for when your y is increasing. Does that make sense? So key thing here is f of x just means y. So looking at function x, when is it increasing? I am.
Wait, what is it? You're just saying like an interval into which.
The intervals of on this function when it is increasing. Huh? Practice it. Here, yes. Approximate. All right, next. I thought they were pretty equal. You just told me the x value. Where means x marks the spot. Is the x not? Yeah, it's like half. That's okay. All right, on constant, you're asking when is it constant? So when is it a unchanging? So pretend that's a straight horizontal line. The value of x when it is decreasing. So now when is your graph going down? And again, when we have f of x is greater than 0, we're looking for positive y. When does the function have positive y values? And then it says when f of x is decrease. Okay, so those are your little clues and cues to know what you're asking for each one. All right, at this point, you're going to be majority asking everyone at your table. If you cannot answer it, I'm the last result. Well, that's the word. What's the word? Resort. That's where we were going. Okay. Yes. Yes. Hit it, August. Mm-hmm.
Did we just list the intercepts?
No, your domain is where does your function go to the left? Where does it go to the right? For the entire thing. Where how far left, how far right? You don't list anything. I was like, what are you doing? Yes. What? When you are describing intervals of increase, that's and decrease, unless it's infinity, it's always brackets. Yeah. And then everything else is just parentheses. Only thing that you're using. All right.